To create the main rotor, we are going to add a new part. So double click on product 1 to exit the part design mode. And then you're going to insert a new part to product 1. Click now to use the same origin, and then Alt Enter. We are going to name this our main rotor section. So main rotor, and on this part, section. Then you're going to double click on the part. So make sure your gallery is visible, and also switch back to material with edges and points, like so. So we are going to start with this shaft, and we are going to create an access system at the middle of this housing. So we can add a point here by intersecting these two curves. Select intersection. This is your first curve. This is your second curve. So we have a point right there at the middle, and then you're going to insert an access system using this point, and make sure the reference is the default, and then click on OK. All right, so we can sketch the ZX plane to create the profile of the shaft. I'm going to switch to the right view to make it easy for me to sketch. The first thing I'm going to do is to create an axis that runs in the middle of the shaft, because this origin doesn't run in the middle of the shaft. So select axis, and at about this point, make sure it's vertical, like so. So you can adjust it until you're satisfied that it's running in the midpoint. So approximately about that point. And then you're going to set to fix it. So constrain it to not move around. For the profile, we can start with this 2-point arc. So select an arc starting with 2 limits. The first limit should be on this axis at this point. Then the second one is this point. Like so. And then to make sure that when we revolve, we are going to have a continuous profile here without a dent. We're going to make sure that this center, so you're going to locate the center of this arc. This center, let me zoom in so I can tell when it's selected. This center should be coincident with this axis, like that. And then you can come back here and just adjust it. Okay, we leave it at that. Now you can select on profile and just complete the rest of the profile. It goes up to here, and then it goes straight all the way down to this body. And at the base, we are going to make a cylinder as the support. So you're going to add a cylindrical surface like that. And then it's going to end at this axis that you created. Then you're going to exit the workbench. And we're going to create a revolve surface. And then the sketch axis, the one that we created, is the one that is going to be used for revolve or for the revolution. The angle is supposed to be 360. And then select OK. You can hide sketch 1. You can also hide intersect one, the point that we created. So we have our first revolution surface. Now we can create the support for the blades, and we just have two supports. It's very simple. One is a hollow cylinder right here, and another one, I don't know if we should check the images. So from this point, so one is going to be a cylinder where we are going to attach, these blades, and another one is not very much showing here, but it's kind of a star. It's kind of a star like so. So let's create it. We start by sketching the star, and you're just going to select the XY plane of this axis system. And we need to project this inner diameter. So I'm going to select that, go back to the normal mode. Hold on, select this and project it as a construction element. Then go back to normal mode. So now you can see where the circumference is. So you're going to sketch a circle, two concentric circles. Make sure you're originating from, we can hide this now, by the way, we can hide that. So from the center, marked by the solid dot, one circle, this is now a standard element, and then another concentric circle from there. And I'm also going to hide this so that I can be able to see this profile. So ideally, this is supposed to be right at the middle. But with the positioning, everything is not perfect, because as you can see, this is supposed to move upwards, but you get the idea. So this circle, we are going to make it a bit larger, say like that, and it's going to be a construction element. Then you're going to select a line. Let's create first an axis. Running in the midsection like that. And then one thing to keep in mind is that this is one of our blades. So the star that we are going to sketch right now, it's going to be attaching to the side of the blade. There's an extension that is attaching. So ideally, one of it is supposed to run here, each at the side of each blade. So at the side of each blade, we're supposed to have a section. So we're going to divide this into 5 sections. So I create 3 axes, and one is going to run about this section like that. You can input them randomly and then just add the angle. So each angle is going to be 72 degrees. That is 360 divided by 5. So the angle between these two is 72. And the angle between this and this one is also 72. So I'm going to rotate this because I want, when I create my first section here, the support system, it's going to be near the blade. So we can come back and rotate this later if we want. Now let's create our first section. And that is just a simple line that is touching this geometry. Like so. I see the problem is this circle is moving. So we need to fix, we need to make it a constant radius. So I'm going to select the circle and give it a radius of 200 so that now it's fixed. And then I'm going to move this angular measurements inside. Like so. And like that. Okay, so now there's no confusion. So make sure this line is coincident with this axis. And it's going also to touch the midpoint here. So we're going to create another axis from this point, touching that line. And then the angle between that and this one is going to be half of 72, which is 36. So we can now mirror this. We can mirror this using this axis. And we can create a corner here. Or before we do that, maybe we can try to create another line. First, mirror this one using this axis. Then select the line and then mirror it again using this axis. This one, mirror it using that axis. I think we need an extra axis here. So I'm going to create an axis from the middle section to this point. And I'm going to mirror this using that axis. So basically just repeat this until you have a complete star. Select this, mirror it using that axis. And finally this one, mirror it using this axis. So we've got a complete star, but we're going to add some corners on support. So I'm going to double click on corner. Make sure it's trim all element on that on that corner. On this corner, on that corner. So we're going to just adjust the radius later on, and then on the bottom corners. Undo that. I don't think I did that correctly. Okay. I think it's picking on this axis. So instead of selecting the corner, what I'm going to do is to select these two elements. That still doesn't make any sense. Okay, let's see this corner. You're selecting the vertex or the two elements. Undo, 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 and undo. Select the first element, select corner, second element. Okay, that worked. Once again, corner between this element and this element. And that's also okay. So for the bottom corners, we're going to have 35 as radius. Make sure the radius part is highlighted. So 35 each. And the top one is going to be 10 each. So that's it. This circle was meant to be a construction element. So we just got a star and then it has this circular hole in the middle. But we also need another whole sections which is going to be connected to the blade section. So you're going to add a circle here. So concentric to this one is a standard element. And it's going to have a radius of 5. Don't know if 5 it's too small. Let's see. Okay, let's give it that was the radius of 5, diameter of 10. That was diameter, my bad. So a diameter of 10 or radius of 5. And then we can just do the same thing we did. Select this section and mirror it using this axis. Select the section, mirror it using this axis. This section, you use this axis. And lastly, you can select this section and mirror it using this axis. So now it's complete. So this is what it's looking like on the top view. So as I was saying, we have a blade here, and then we have a section extruding to the side, which is going to be joining with this using a rod. So to rotate it, you can adjust it here. You can adjust the rotation and also the length. So it's very versatile. I'm going to leave the length about that point and rotate the section just a small distance from the blade. Okay, so that's okay. You can now exit. Let's go to the side view. So it's right at the top of this housing section. And for this part, I'm not going to use surfacing tools because the geometry is kind of complex. We're just going to go straight to the mechanical design pad design workbench and just create a pad. So I wanted majority of the surfaces to be created in the GSD or the IMA workbench, but when it comes to some complex profiles, it's better to just use the part design, so we don't have to fill a lot of sections. Let's go to the side view. So our profile is this sketch, and we're going to extrude it upwards because remember the axis is sitting right on top of this surface. So we're going to extrude it upwards. Now upwards. And then we have the limit here, limit 1. And I'm going to make that to be, actually we can leave it at either 20 or 30. Okay, 30 looks good. So that's going to be in the part body, part 1. And then we have a cylinder right here. So what we're going to do, let's go back to generative shape design workbench and do a translation. Translate this axis system using this Z axis. No, here it's the Z axis. Direction is the Z axis. So make sure it's selecting the Z axis. Okay. We're going to bring it up to where the blade sections are. So that the XY plane is sitting at the center of the blades. So say about that point and select OK. Once again, just sketch the XY plane. And this is again our shaft diameter. So we're going to project that. Then just create another concentric circle. Like so. And exit. Then now we can create now a pad. So we're now going to be switching between this pad design workbench and the GSD. We're going to select a pad. I'm going to select mirrored extent because we put it at the middle. And just match the width with the blueprint. So about that point. And then select OK. So this is where we are going to be attaching our blade sections. And then we can start with the first profile by selecting the ZY plane or the YZ plane and sketch. The YZ plane, we are going to sketch a circle from this center like that. So just approximate, just less than this width, and then exit. Then because we have a shaft in the middle, we have to start our geometry after that shaft when we are protruding. So you're going to select a pad, reverse the direction. So limit 1 is going to be almost here at the very end, so that we make sure we are clearing the inner section. And then the outer section is going to be according to the blueprint. So this section, this is the cylindrical section. Select OK. So that is pad 3. Now, as I said before, we are still going to be using the NACA. We are going to be using the NACA 0012 aerofoil to create the blade section. Now, what we need is the chord length of the blade, which you can obtain by going to the top view. So if you select this XY plane, this is the XY plane, and sketch it. Select top view. You can create a line from the edge of the blade to the other side, and then check the length of that, and that is going to be our chord. So it's about 185. 185 millimeters. So that's going to be our chord for the blade. And we can go to airfoiltools.com and enter this in the NACA 0012 airfoil plotting section. So undo this. So that's 185. Before we get to the blade, I'm going to create an aerofoil. So we're going to have an aerofoil section that is also going to be joining to the blade section. So from the circle to, not an aerofoil, but I mean an ellipse, to an ellipse section here. So I can sketch it here and then translate it, so we don't have to keep creating other sections. So I can sketch this YZ plane. Hold on, we are still in the workbench. Hold on, let's exit. Okay. Undo this. Okay, if we sketch the YZ plane, we can sketch an ellipse. Okay, select ellipse. Make sure it's horizontal, and here it's also vertical. And this horizontal distance is going to be, so we said for the blade section is 185. So it should be about the same. So we can do 190. Exit the workbench. Go to the GSD workbench. Translate this sketch. The direction is this X component. Then you can go to the top view and you'll be able to see where you are placing your section. So it's at this point. Select OK. So we're going to use a multi-section surface. Between this circular section and this ellipse, just make sure the directions of the tangency are coinciding. Preview. And here you can actually go to coupling methods. You can switch between ratio or select tangency then curvature and see which works best. I think they are almost the same. So I'm going to leave it at ratio. Select OK. So now we have a surface section here joining this base, and then this is going to join to the blade. So now we need to sketch what the NACA 0012 aerofoil. I'm going to select this axis system. We can hide this sketch. Select this axis system and translate it. All right, so the distance, the direction is going to be the X component. And then we're going to make the distance about this point, just close to this surface. Now we have two options. We can create the airfoil section here and just blend it, or you can try to create like a mechanism which is holding the airfoil here. There's usually like a clamp that is joining this section to the airfoil section. But first, let's plot it. So you can measure this point so you can get the coordinates. So the distance between, now that's measure between. We're going to select this measure item. Select this point and it's going to give you the coordinates. So we're going to write this one down. So for X, it's 2484.71. Y, it's 27.796. And Z is going to be 2642.534. So that's going to be our origin when plotting. Alternatively, we can just ignore this, plot it at the origin, and then do an axis to axis transfer, which I think it's more preferable. So what we're going to do is we're going to locate the one that we created previously. We can do that and just adjust the code, or we can just go and plot one with the exact code that we need. So I've already taught you the procedure, so I'm skipping ahead to the plotting section. And the code right here is going to be 185. 185. Then plot. And save the CSV file of coordinates. Open the file. So we're plotting on the YZ plane. So that means that the X is constant, and therefore this is going to be our Y and Z coordinates. Y and Z coordinates. So X is 0, Y is equals to X, and Z is equals to Y. Then just drag this all the way to the end of the section. Hold on. Okay. Up to this point. Up to this point. And then we have the Y. Do the same for Z. Then you're going to copy these and paste them in the GSD Excel file. Again, you already know the procedure. We have to open our section in a new part window. So I'm going to click on main rotor, right click, and then select open in new window. That's because we cannot plot in the product mode as I mentioned earlier on. Now you can run the macros. And we've plotted our section. So I'm going to check the front view to confirm. Yes, and our section is supposed to be in the front view, but it's facing this side. So again, I'm going to just select the spline and the first point. The first point and the spline. And I'm going to mirror that. So select symmetry using the ZX plane. Hide the initial element. Select OK. So we can hide everything here. We can select everything and then click on Control and select this as well as the point. Hold on. In fact, I can deselect it from the specification tree. So we can press Control, deselect the symmetry. Select everything and deselect the symmetry as well as the points, the planes I mean, as well as the 3 planes, and then hide the rest. So we have that. Now we need to close our profile, and this time we can now use we don't have to use a spline. We can use connect curve. Connect curve, first point, and okay. And then the second point is going to be this point, which is also tangent to symmetry 2. We're going to reverse these tangency directions like that. And we're going to increase our tension to, let's say, 5 each side. So it's a bit pointed, and select OK. Now we can insert an axis system on this point so that we can do an axis to axis transfer. Save your work And you can exit this window and we'll have everything we just created on our new window. So now we can transfer them, and I'm going to go back to this geometrical set and define it in work object so that now our new elements hold on, which geometrical, yeah, goes to this geometrical set and not this one. So I'll do an axis to axis transfer. The element is going to be a join. We're going to create a join. Don't know if we have an option to join here. We should have an option for a join. Yeah, create a join between this symmetry curve and this connect curve. Select OK. All right, and then the reference will be this axis system. The target will be where we want to place it. So it will be this axis system. And select OK. Let's go to the top view. And actually, it just occurred, I just remembered that if we transfer it here, it's going to start from this origin point. So we need our origin to be at the end point. Okay. So I'm going to top view. And I'm going to translate this axis system. The direction is this Y. I'm going to translate to where I want my section to begin, which is about that point. Hide the initial element, select OK, so that now it starts from here and extends. Okay, so let's transfer it. Select axis to axis transfer. The element, we are going to create a join between the connect curve and the symmetry curve. The symmetry curve and the connect curve. Let me zoom in so I'm able to select. Preview. And I'm also going to add the point, so I don't have to make many extremum points. So that point, close. The reference is this axis system. The target is this translate for. Hide initial element. Let's see. Okay, we've got it here. Select OK.